Joe.
I don't know if you want to introduce me or if I should just hide in the back. Or I can
introduce
myself.
you, sure, yeah.
Usually I don't.
Okay,
But
okay.
it's a small class, and so
yeah,
you
yeah.
might wonder
Like, who is this
strange
person?
person here. So do whatever you want, or I can introduce myself or whatever.
Okay, sure. Sounds good. All right. Okay, let's go ahead and get started. We'll start with a few announcements, okay? So I released the midterm grades on Friday, okay? Friday afternoon, so you should be able to see them if you go to Canvas. You can also access them in EdSTEM itself, okay? And importantly, we really want to emphasize you should check to see what you got wrong in EdSTEM itself, okay? You can actually go to the practice midterm lesson, just like you did during the exam. And we've changed the settings so that you should be able to see the solutions. If one of y'all want to try going and seeing the solutions and let me know and make sure everything is good there, please try that right now and let me know if there's an issue. But I think you might even have something on the right that says feedback or explanation. I just don't have the student view right now, so I'm not able to show you what it'll look like on your end. But please do go through and you can see exactly which questions you got wrong. And then also on the rainfall problem, because I know the rainfall problem was one where we also had some manual grading. You can also see how we applied the manual rubric, okay? If you have any questions on the grades that you got for any of these, or you just want to go over some of the questions, please come to office hours. My office hours are going to be tomorrow right after lecture, but of course you could also go to any of the tutor hours or TA hours that are on the course calendar. Are there any questions about the midterm grades? Not specific to your individual grade, but any questions or concerns about the midterm itself? Remember, you can improve your midterm grade through the final exam, okay? Like, let's say you got a 50% on the midterm. If you get a 90% on the final exam, your new midterm grade will be the average of the two, okay? So, if you're not happy with your score, that's totally fine. That the course is not over. You definitely have chances to improve your grade after. All right, other announcements for the PAs. Programming assignment 4 is due today, but remember you can use up to 2 slip days, so you can turn it in on Wednesday if you'd like. And the 5th programming assignment is going to be released today, and that due date is going to be Friday, okay? Programming assignment 5 is a bit more difficult, I think, than the previous ones, and part of that is just the amount of time that we have to complete this programming assignment, and the things that we are going to learn today are definitely going to be sort of new in that it's very different from things that we've been doing before in this class, okay? So please come to office hours if you need any help with programming assignment 5, and I really want to highlight that the discussion sections, okay, the discussion sections this week are going to be extremely helpful for the programming assignments, okay? So I highly encourage attending discussions, but you could also watch the podcast of discussions if you're not able to make it in person, all right? And then finally, we are going to start this process of one-on-one tutoring if you want to use this option. So we have the link here on the slides. and you should be able to access these slides. Let me know if you can't. But this is a Google form where if you want it, you can sign up for individual tutoring with either one of our TAs, one of our tutors, or Ismail and I. You'll be asked to just enter your schedule. I wish it was loading right now. Oh, wow, that's perfect. All right. So you can also have the option to do these individual tutoring things remotely. And then you can enter your preferred day and time, and then we will work out among our course staff someone who will be able to meet with you during that time, give you help on going through the midterm exam, going over the programming assignments, or just reinforcing material from the lecture, okay? Just to also highlight why this is going to be useful for y'all now, if you take a look at our course schedule here, okay? We're here on Monday, July 21st. It feels like we just finished the midterm like a couple days ago, right? Which it was like last Wednesday. But our final exam is now going to be in about 10 days, okay? So this class is definitely starting to pick up a little bit in these last 2 weeks. And so I really want to highlight the usefulness of discussions, the one-on-one tutoring, or just coming to office hours to clear up any questions you have on the lectures. Yeah, Ron?
You don't have access to the Google Form.
You don't have access to this Google form. Okay, let me change that right now. This Google form you don't? Oh yeah, let me make it public to anyone with the UC San Diego email. If you're not able to access it right now, just make sure you're on your UCSD email, and then hopefully you should be able to. Let me know if it's still an issue. Any other questions about any of these announcements? Was anybody able to check the midterm? Were you able to see the explanations and solutions? Okay, great. Also, I forgot to introduce the person sitting in the back there with the red hat. This is Joe Politz. Joe is a professor of computer science in the department. He's a mentor for all of the graduate students that are teaching this summer. So he's here to make sure that I'm doing a good job in teaching y'all. But if you keep taking computer science classes in the department, there's a high chance that you would take a class with Joe because he teaches stuff like CSE11, CSE29. So yeah, if you keep taking classes, you'll definitely encounter Joe in your future.
I just want to amend the record. I don't make sure you're doing good. I know you're doing good.
Oh, wow.
I give feedback to all of you so that we can do an even better job.
Okay, awesome. Yeah, so that's who is sitting in the back there. That is like a new person in these lectures. But sorry, any other questions for the announcements or programming assignments? All right, let's get into today's material. And I want to quickly remind everybody what we went over on Thursday. I know Thursday was like our first day of material after the midterm, and it was a pretty big jump in things that we've been doing. We used to just be writing simple for loops, right? A single for loop. And now we're using these things called nested for loops, okay? I really want to make sure we have a solid foundation here, because the thing that we are going to work on for the next week, okay, like all of this week, we are going to be working on something that was, the title of this lecture, which is images, okay? We're going to do a lot of fun, like cropping and like filtering and modifying images, but the foundation of everything we're going to be doing this week is nested for loops and two-dimensional lists, okay? So I want to start off with a review exercise, okay? And in this review exercise, you're going to actually be writing code in EdStem. So please go to your lecture 13 lesson, okay, in EdStem. Just in the same place the lectures have always been. And let's go to this first lesson, okay? When you open up like the first slide in this lesson, you should already have like just this list of lists. I'll give y'all a second to get there. And once you open this up, I'm going to give y'all about 3 minutes to just write a nested for loop, okay? Write a nested for loop that just prints out all of these numbers 10 through 90 one by one, okay? We covered this in last lecture, but you could refer to past materials if you want. Just want to make sure we have a solid foundation of how to write a nested for loop and go through this list, okay? So I'm going to give you all about 3 minutes to do that. And then we will go over it after those 3 minutes. Let me know if you have any issues accessing it still. I'm just going to write the first line here if you're struggling to get started. Let's say for each LST in data. Okay? This is just a helpful first line if you're struggling to get started. Just take 1 more minute here. It should just be about 3 lines of code that you have to write. And if you finish this already, I have this question here of what if I only wanted to print things along the diagonal, okay? What if I only wanted to print 10, 15, 90? You can try working on that if you've already finished here. Okay, let's go over this question right now. So let's start with just that initial task, right? Where we wanted to print out 10, 20, 30, 40, 50, each on its own line, okay? I gave us this first line here on line 5. So say I just did like print each list, okay? If I did something like this, can anybody let me know what would just be printed on the first line here? If I ran this code on lines 5 and 6, what would be printed on the first line here? Does anybody tell me? Yeah, Jilan.
I think it would be 10, 20, 30.
Yeah, it would be 10, 20, 30. Let's see what happens if I press run. Okay, yeah, exactly, right? It would be 10, 20, 30 because right now, when we have this for loop going through data, okay, each list is going to be literally every individual item in data, okay? It doesn't matter if that item is a list itself, if that item is a number, if that item is a string. It's going to print out the whole first element in data, okay? And that's why it's like 3 lists here. So how do I actually improve this to make 10, 20, 30 appear on different lines? I'm going to get us started here. I'm going to say for, let's say each num in, what goes in this underlined thing here? Can anybody tell me? So now we want to access each individual element, okay, in the list. What would we actually want to put in this blank here? Anybody know? Yeah, Arnaldo?
So like the first for loop is accessing each line, right?
Yeah, accessing each list.
Each list. Okay.
Yes.
So now I want to iterate through each list.
Mm-hmm.
So for each num in each list.
Yeah, let's try that. Let's do each LST. And then I'm going to do print. You know what, for some reason these indents are huge. I don't know, is anybody else noticing this? It's just when I'm tabbing, it's like a huge change. I think it'll still work, but I think there might be some setting that's a little different. Sorry for that aside. Let's try this then, okay? Let's do print each num. And now if I run it, and we can scroll up on the output, we are able to see 10, 20, 30, 40, 50, etc. So just to highlight what's going on here, first, each list is going to be like the inside lists in data, right? And then just like what we've been doing before in the whole first half of the class, right? We now just want to write another for loop to go through each of those individual numbers, okay, that is in each list. So when we print out each num now is going to change from 10 to 20 to 30. And then we'll have finished this loop, and now each list moves on to be 40, 50, 60. Okay? Yeah, Vaughn?
Could you do it with like for I and like a range?
That is an amazing question, and you got to what I wanted to do next, okay? So what if we just wanted to print things along the diagonal? Okay, that was that question that I had in the slides here. What if I wanted to print like only 10, 50, and 90, okay? If I only wanted to print those, but still having the double for loop, okay? Does anybody just have any idea, like just explaining it in English, what I could try to do to make that happen? This is a hard question. I'll give y'all maybe like 20, 30 seconds to think about it. What if I only wanted to print things on the diagonal? If anybody has an idea, feel free to raise your hand and share. Yeah?
I would say if we're looking at each individual list, you would add one to the index to make it just so it goes in that diagonal.
Oh, interesting. So like maybe we would start here at 0, I guess, and then this next one we'd want to print index 1 and then print index 2. Oh, that is interesting. Okay. That is fascinating. That's not the solution I was thinking of, but let's just like maybe show what I think you're imagining. Let's say we just had a variable called index 0. And if we do for each list in data, okay, we could just say print each LST IDX. And then I think you're saying IDX plus equals 1. And then the next time we go through the for loop, IDX would now be 1, and then it would be 2. And like each iteration of the for loop, we would keep increasing IDX. This is a little complicated. Let me just try running it to see if this works. Okay, this does work, but I would say this was a really creative solution. I was thinking of something a little bit different to sort of get at the idea of like what Yvonne was asking, could we use for I in range? But this was really cool as well. Thanks for like sharing. I don't know if this is exactly what you were saying or not, but this does make sense and this works. But let me show what I was thinking of with using for I in range, okay? So let's say we do for I in range, but here's one roadblock. What would we actually put? I'm going to remove this code, okay? I'm going to remove line 7 and 8, and I'm also going to remove line 5 here. If we wanted to go through and print out like all of the numbers using for I in range, can anybody tell me what we would put inside the parentheses here in range? Remember, we need it to eventually be a number because we have to put a number inside of range. But what would actually go into the parentheses here? Any idea? Yeah, Giovanni.
Each piece.
It would be what? Sorry?
Each piece.
Each list. So do you mean something like this?
Yeah.
So let's think about this for a second, okay? If we just have this code, and this is going to be like a really important concept, right? Any variable that we are using, okay? In this case, each list would be a variable, okay? The problem is we haven't actually created this variable, okay? If I run this code right now, and let's say I just have something like this, print I, okay? I just have something like this and I run it. I'm going to get an error because we haven't actually created the variable each list yet, okay? But what we do want is we want to know how many things are in data, okay? We want to know how many things are in data so that we can actually go through each thing in data, okay? So remember before we were doing like for I in range len of something, remember we were using that function called len a lot? That's a very standard template, okay, that we are going to use even in the case of double for loops, okay? So let me actually just show what we would do here. For I in range len data, okay? Can anybody tell me what is len data here? Just in this code, what would len data be? Yeah, Arnaldo?
Len data is 3.
Yeah, why is it 3?
It's counting, it's counting each like initial list, like the first dimension. Is that what I call it?
Yeah, cool. Yeah, first dimension. Okay, we're sort of getting to this idea of 2 dimensions now. That's awesome. Yeah, maybe a different way to put it is you would just count the number of items in data, okay? Whether that item is itself a list or an integer or a string, it's going to count how many things are in data. And there's 3 things in data, right? There's, 3 things that are separated by 2 commas. And so this would give us 3, okay? So if I run this code, it's going to print I as 0, then 1, then 2, okay? But now, if I wanted to actually do the double for loop, okay, let's use a different thing called j. For j in range, and now here is also a tricky roadblock. What would we put inside of this? Okay, what would we put inside of this such that we could go within each individual list? Let me actually just show you what we do with this. Let's say print data I, okay? Remember, since we're doing for I in range, I is going to be the numbers, 0, 1, and 2. And so then we want to print out each of these lists, right? 10, 20, 30, 40, 50, 60, 70, 80, 90. We would have to actually access, okay? We have to access each of those individual lists using our variable I, okay? So I just want to run this code so that we get to this like intermediate part that we also had last time, where now we're printing out each list, which is great, right? We're like halfway there. But now we want to add that second for loop, okay? So what would this be? What would we put inside these parentheses? Any ideas? I'll get us started. Oh yeah, Arnaldo, go ahead. Huh?
I?
For j in range I, like this. So what would I be the first time we ran through the for loop? Like the first time we ran through this for loop, what is I?
The first line.
So that's a great, so there's a difference here between what is I and what is data index I, okay? So let me actually, let's not go so fast, let's do this, okay? Let's print, okay? Let's print I, and then we're gonna print it like this, and then we're gonna say data I, we're gonna print it like this, okay? And then just so that it's a little easier to read, I'm gonna put a new line here, okay? So I'm gonna run this code, and let's scroll up so we can see the output, okay? So this is like the big difference between doing for I in range and then doing for each list in data, okay? First, I is equal to 0. Remember, anytime we do range, I is always just a number, okay? I is not going to be our list, it's just a number. So that's why we have to do something like data I, okay, to actually get the full list, okay? Does that difference make sense to people? Are there any questions there? Okay, so this is the big difference here, that I is a number when we have range. So now let's get back to what we were just on. I'm going to keep this print statement here, just so that we can remember data I is how we access each list. So now that we have data I as a list, now we just have this new subproblem of how do we print out each individual thing in 10, 20, 30. Okay? I'm going to comment this out and run it just so we can see. Right now, data I is 10, 20, 30. How do we go through and print out each individual thing in data I? Yeah, go ahead, Arnaldo.
Oh boy. Is it going to be data ij?
Data I, like this,
Yes, and then
also like this.
j?
You are close. You're jumping the gun a little bit, okay? What is data I here? What is data I? Like the thing that is being printed out.
In the first iteration, we're going to have the first line. Data,
Yeah.
It's going to be data 0.
Yeah, basically, right? It would be 10, 20, 30.
Yes.
It would be that list. So I'm actually just going to show what we would put now and then explain why that is the right answer. We wouldn't need this j, okay? Because when we add that j to the end, that is just getting like the very specific number, okay, inside of data I. Instead, though, what we want is something like this, okay? Len data I.
Okay.
And so remember, we just discussed what data I is, right? Data I is this list 10, 20, 30. So what is the length of data I? What would this thing on line 7 be equal to? What would len data I be? Can anybody tell me? What would len data I be? 3, right? And so I think what makes this confusing is because we have, like 2 for loops and a list inside of a list, okay? Something that I do that really helps try to like make it less complicated when we're doing these like lists inside of lists is just break it down into 2 different questions, okay? At the beginning, before we even start writing the for loop, just think about writing a for loop to go through each thing in data, okay? Let's ignore the fact that it's lists within lists and all that stuff, okay? We just want to break it down into 2 different questions where first, we just want to get access to each of these inside lists, okay? First, we just want to get access to each of those inside lists, and that's why we have lines 5 and 6, okay? But then, once we do actually get access to each of these inside lists, now it's just a new problem that we've already seen before, right? If I already have a list, I just want to write a for loop to go through that list, okay? Just to be clear, we have done this before. We've done this last week and in week 2 of the class as well, but now we're just kind of putting 2 things together, and it's like a for loop inside of a for loop, okay? But as much as you can, if you could try to like think of these as 2 different questions and solve one question before the other without getting too ahead of yourself, it might help with understanding the complexity of these things. But after we do this, okay, we've like made it through writing both of the for loops. Now, how would I just print out 10, 20, 30, 40, each on its own line? Like what Yvonne had asked was, can we do that exact same question with range, right? So let's see if we can do the same thing with range. What would we actually put in this print statement here to get each individual item, each individual thing like 10, 20, 30? And I'll give a hint that Arnaldo was on the right track with one of his guesses. I'll get us started with this. We're going to do something with data, but what would go after data here? Any ideas? Anybody have a guess? okay, how about this? Would it be data I? Can someone tell me yes or no for this? Just yes or no. Is this?
No.
Okay, why not?
If we only do data I, we're only printing that first line, and that's going to probably print 3 times.
Exactly, yeah. So if we just do data I, remember, we already saw data I, right? It's 10, 20, 30, and we print that 3 times, okay? And then we would go on to the next iteration of the outside loop, and then we print 40, 50, 60, 3 more times. But I actually have to add something to this, okay? So that I don't print out the full big list. I have to add something inside these brackets. What would it be? What would I put inside these brackets? There's really only one variable here that we haven't used yet. Any ideas? Yeah, Jialan? It is J, okay? It is J. So let me run this just so that we can see, okay? Right now, what we've done is we're saying I, okay? I is going to be 0, 1, 2, okay? We saw that very early in this example. J is also just going to be 0, 1, and 2 because it's going to go through how many ever elements are in these smaller lists, right? So what we're really just doing is, if you think about this, this is getting a little bit ahead of what we're going to cover in today's lecture. I and J are just covering the rows and columns, okay, of this grid, okay? I is first going through each row, right? I was 10, 20, 30, 40, 50, 60, 70, 80, 90. And then J was just getting us each sort of column in those rows, okay? This is going to be a very standard format that's going to be super important for this week of the class. That's why I'm spending so much time on this example, okay? I really want to make sure that we're familiar with this general principle of using these double for loops to sort of like go through a grid. Are there any questions here on just this part of the example? Why we have to do data ij? Are there any questions here? Give y'all a second. Yeah, Arnoldo.
So we did 2 different for loops that, correct me if I'm wrong, that essentially did the same thing?
Yeah.
Okay.
The output ended up being the exact same thing, but if you actually look sort of like what's actually happening is that I and j here are numbers, okay? And then we had to do this like data ij thing, rather than just printing out each list or each num, which were like the variable names. So it is doing the same thing on the surface, but we're approaching it a different way. And I just want to wrap up this example in a minute or two here. But are there any more questions? Any more questions with this? Yeah, go ahead.
Is this called embedded for loop?
Nested for loop is the term we're using in this class. Yeah.
Thank you.
So what if I wanted to just print things along the diagonal? Okay, just things that were like 10, 50, 90. And the reason I'm doing this example about printing things on the diagonal is your first question in programming assignment 5, okay, is going to have this sort of trick in there where you might need to do something with, things along a diagonal, okay? So let's think about that closely here. What if I just wanted to print out 10, 50, 90? Can anybody think in common, what do 10, 50, and 90 have in common? What are their positions in the grid? Let's actually write this out here, okay? So if we have this grid of 10, 20, 40, 50, 60, 70, 80, 90, okay? What do 10, 50, and 90 have in common? Any guesses here? Yeah, go ahead, Arnold.
They have matching indices.
Wow, yeah, what do you mean by that?
So like the index of the first line is 0.
Yeah.
And what we want is that first entry on that first line, which is 0.
Yes, yes, yes. And so the columns are like 0, 1, and 2, right? Does this make sense? We have like the row and column. Should have left more room at the top there. But in each of these, okay, we have it where the row index is the same as the column index, okay? Thanks for closing the door, Arnoldo. It was getting loud, I didn't even realize. Does that make sense, that the row and the column index along the diagonal is the same? Are there any questions there? So, okay, so I'm going to want to have to use a print statement because we only want to print out a certain number if something is true, right? For this question about printing things along the diagonal, I only want to print out those numbers if a certain condition is true. What is that condition? What would go after this if statement? If what? We heard, like in plain English, that we want it when the row and the column index is the same. What are the row and column indexes in our question here? If, any guesses? There's only a couple variables that we're working with here. All right, I'm gonna go ahead and share the answer, okay? We wanna do it if I is equal to j, okay? We only wanna print out the number if I is equal to j. I'm gonna just run this so you can see that it's true. And again, the reason that this is true, I know I've written row and column here, okay? Really though, this is I, the rows are I, okay? And the columns are j. Okay? I'll give y'all a second to like digest this. Does everybody understand that the i's, okay, for I in range are the rows, and j is the columns within those rows? Are there any questions here? Please ask them now, because the whole next 3 days of lecture are sort of built on this idea. Okay, let's go ahead and move on then. What we do for these next 3 days is just going to be sort of like a remix or like adding a few things on top of this basic concept, okay? So please feel free to interrupt and ask a question, even if we have to revisit this idea of 2D lists, okay? Awesome. Okay, so today we're going to talk about images, okay? Images are something you have like all seen, whether it's on like, social media or even within these slides, we constantly have images. But the way that you could think about images in a programming sense, okay? Images in like a programming sense is just like what I've drawn on the board there, okay? This idea of like a grid, okay, is exactly how you can think of images. But the question is like, what is each thing in an image, right? Like if I see a picture of a cat, okay, if I see a picture of a cat, let me actually just show y'all, because this is going to be the next thing in your workspace. So if you go to that same EdSTEM lesson and click on this second thing, okay, you can actually click on something called files here. I know we haven't used this button yet before, but you are going to start using this button now. If you click on files and then see under images, okay, we have a few photos here. I'm gonna just click on cat. So now you can see a photo of a cat, okay? By the end of this lecture, we're gonna start like manipulating this cat or this image of a cat. But first we need to understand like what this image even means, okay? You don't see it like when you're like just visually inspecting this right now, but this cat image actually has like, it's a giant grid, okay? It's a giant grid of something that we are going to call pixels, okay? It's actually also called, pixels in the real world, but That's going to be a key term here, okay? An image is just a grid of pixels, okay? And so this would be a 2x4 image, okay? The height is 2, and the width is 4, okay? And what this means when we say like a 2x4 image, okay, is that we have 2 pixels, like the height is 2 pixels, and the width is 4 pixels, okay? Does that part make sense? If y'all have ever, like, I don't know, seen like ads for TVs or something, or like monitors or anything, they say things like, oh, this is a 480p TV or a 4K TV. Those generally are about like how many pixels are in the like screen, okay? If you have like way more pixels, then you get to see like some really sharp images, okay? Because you get a way more like fine-grained differentiation when you look at a screen with more pixels, okay? If something is very few pixels, like if you actually had a screen, like a TV that only had 8 pixels, okay? Each of these pixels can only be one color. So you can imagine like, it would be really hard to see like a cat, okay? It'd be really hard to see a cat if you only had 8 pixels to work with, okay? Just so that we understand like what a pixel is in the real world. Are there any questions here on just thinking of images as a grid of pixels? Okay, so these are just a couple examples here. You can see that each pixel has an individual color, okay? That's going to be a fundamental each pixel can only have a certain color, okay? But we still have this issue of what exactly is a pixel, okay? In programming, when we're going to work with these images, is a pixel just a number? Is it a word? Like, can pixel equal the word black or pixel equal the word red? How do we actually like get from this idea of a pixel to like a certain color, okay? And now we're going to introduce something new, okay, called tuples, okay? I pronounce it tuples, some people pronounce it tuples. I'm just going to say the word tuples, but I think feel free to pronounce it how you want. Not sure the exact pronunciation. But a tuple, okay, is a new data type, all right? So we've learned a few data types already. We've learned about integers. We've learned about strings. We've learned about booleans, right? Those are some of the more simple data types. But then the data type that we've learned that's most similar to this is a list, okay? Remember, we've been working with lists for the past few weeks now. But a tuple, you can think of as like the cousin of a list, okay? They have some similar properties, but they're also like very different. Once we actually start using them, you'll see how they're different, okay? So we already noticed some things that are similar between a list and a tuple, okay? A tuple lets us hold multiple things, right? It's a collection of different things. Here, we have a tuple that has a length of 3, okay? So just like a list, right? If we had brackets around this, we would think of, oh, this is a list with 3 numbers inside of it, okay? You should also think the same thing when you see this with parentheses. And the parentheses are going to denote that it's a tuple, okay? So one of the differences between a list and a tuple is that a list has brackets, a tuple has parentheses, okay? And it can hold multiple things, just like a list. But that's sort of the main similarities between a tuple and a list. I don't want you to start thinking that a tuple and a list are like interchangeable or the same, because they're actually very different. And we're going to get into some of those differences. But just on this concept, that a tuple holds a collection of things, are there any questions here? It doesn't always have to be 3 things. It can be 2 things, it can be 8 things, it can be sort of any number. Are there any questions here? So that is the idea of a tuple in general. But the question I had asked that led us to this slide is, like, what does a pixel actually mean, right? Like, how do we represent a pixel to show different colors, right? Because on this previous thing, we have, each pixel is like black over here. It's like the outline of Santa. But then we have some like yellow pixels over here. We have some red pixels in the hat, okay? So the way pixels are actually denoted is a tuple with 3 numbers inside of it, okay? There's 3 numbers inside of our tuple, and those numbers, represent red, green, and blue. So let me actually just open this, and I'll put it here. So let's say pixel equals 0, 0, 0, okay? When you see something like this now in the class, you should think of each number in a pixel being a number for the red value, the green value, and the blue value, okay? I've written this as a comment here just so you can see that we hear this thing RGB. I don't know if you've heard this like little sequence very much, RGB. RGB just stands for red, green, and blue, okay? Each number in a pixel represents like how much red we want in that pixel, how much green we want in that pixel, and how much blue we want in that pixel, okay? Red, green, and blue together, okay, with like the right mix of all of these things can create pretty much any color. I think there's like a whole field called color theory that talks about like what colors you can and can't make with different mixes, and there's like primary and secondary colors, okay? But for this class, all you really need to know is that the colors that we see can always be created by just a mix of red, green, and blue to different extents, okay? So what if I only wanted a red pixel? If I wanted a red pixel and I wanted no other color in it, okay, what I would do is actually make this 255, okay? Forgot to mention this, but each of these R, G, and B can only take on a number from 0 to 255, okay? It's basically like how much of that color do you want to be represented in the pixel, okay? So if I wanted a red pixel, I would just make the red value go all the way up, okay? And I would make the green and blue values be nothing, okay? I would want the green value and blue value to be nothing if I wanted a red pixel. If I wanted a black pixel, okay? If I wanted a black pixel, black is just the absence of any color, okay? So a black pixel would actually just be 0, 0, 0, okay? At a high level, a pixel is just a representation of how much red, green, and blue are going to be present in that specific pixel, okay? Are there any questions here with what a pixel actually looks like? We're definitely going to dive in now onto how these come together to create an image. I want to make sure we're all clear here. Are there any questions here? Okay. So this is how we are going to be using tuples in this class. We're not going to go too much into tuples beyond using them for pixels, but there's a really, really important concept, or a couple of concepts that you need to know about pixels, okay? And that is, I'm going to put it in a comment here, tuples, sorry, I don't know if I said pixels, a really important concept about tuples that we want to be clear on. I'm going to put it in all caps. Tuples are immutable, okay? Remember this word? We learned about this word when we were talking about references. Can anybody tell me between strings and a list, okay, those are the things we were looking at the most, are strings mutable or immutable? Are strings mutable? Can they be changed? Or are strings immutable? Can they not be changed? Does anybody remember? Can we change strings? Yeah, go ahead, Arnold.
No.
We can't change strings, right? So let's just show what I mean by that. Let's say I just have name is my name, okay? and then I wanted to make the first letter capital, because I'm like, hey, names should be capitalized, right? And if I just try to do print name, okay, if I try to do print name and run this, I'm going to get an error because I can't reassign or assign one character inside of a string, okay? Tuples are this exact same way, okay? We cannot change tuples, okay? We cannot add things to tuples. We can't make it go from a 3-length tuple to a 4-length tuple. There's no like append for tuples, okay? This actually makes tuples sort of, I think, easy to grasp because when we create a tuple, it can never be changed, okay? It can never be changed. When I write something like this, pixel equals 0, 0, 0, okay? This is always going to be this tuple. It's going to be 0, 0, 0, okay? I can create a new tuple if I do something like pixel equals now like 255, 0, 0, just like with strings, right? Just like with strings, I can't I can't change something that's already inside a tuple, okay? If I wanted a new variable called pixel that is a tuple, I would have to do this whole thing, okay? Let me show you this with like a quick demo, okay? When you think of tuples, I want you to think of the analogy with strings about how we can't change them, okay? So if I had something like this, where I had black equals 0, 0, 0, okay? But then I was like, actually, I want to change this to be red, okay? I wanted to change this to be red, where it should actually be 255, 0, and 0, okay? I can't do black 0 equals 255, okay? If I do this, I get the exact same error message that we kept seeing with strings when we tried to change strings, okay? I cannot change a tuple. And this is like by design. There's some pretty good reasons for why we want tuples to be unchangeable, okay? It's like when we create a tuple, we know it can't be like accidentally changed or accidentally modified. And it's more of like a guarantee that when we write or create a tuple, it can't be like easily changed, okay? There's definitely more reasons why a tuple is like unchangeable, but for now, let's just think of it as this. We want it to be constant, okay? So, because I can't do this, right, what I've highlighted here, because I can't do this, okay, if I did want to update this, if I wanted to update black to actually be 25500, okay, I would have to reassign. Remember that term reassign? I can't just change it. I have to reassign it by doing something equals something, okay? For a tuple, we need to always have it be equal to something. We can't just change part of it. So it would be more like black equals 255, 0, 0. At this point, it would just be a red pixel, but just to show you and like belabor the point that I can't update a single element, I have to actually reassign it by making it equal to something new, okay? We can't append or anything. We can't do black dot append. We can't do like black dot append 0 or something, okay? I'll get this error that tuple has no attribute append, okay? Tuples can't be changed. They're immutable. Any questions about that? Okay. I think we're pretty much ready to start using what we have just talked about and start putting pixels together, okay? Before we do that, because that's going to be, putting a few different concepts together, are there any questions on what I just went over? On tuples not being able to be changed, or about what a pixel really means? Yeah, Devon.
It's not really for like tuples, but it's like for like for loops. When do you have like a general rule that you follow when you use for I in range versus when you do like for each list?
Yeah, that's a great question. I think this is a common misconception or a common thing that is hard to grasp. When do we do for I in range? And when do we do for each list or each number in a list, okay? Generally, like we saw in the example that we started today with, they can do the exact same thing, okay? If you just have like a general for loop question, you could typically use either one. But the way I think of it is that there's only some cases where you have to use one or the other, okay? And one really important case where you need to use for I in range, okay? I want to write this somewhere, but I don't know where. Let me just put it here, and then you can copy it into your notes, actually. So I'll say like for I in range, okay? This is used when we need to access the indexes, okay? When we need to access the position of things, then we should absolutely use for I in range. Let me say when we need to get the positions or indexes, okay? Now, in this example, okay, of the diagonal, all right, in this example of the diagonal, remember we were talking about like what is the similarity between 10, 50, and 90, between things on the diagonal, okay? And we talked about it in terms of their positions, right? We were like, the row number and the column number have to be the same for us to know that it's on the diagonal, okay? And so if we get a question like that, and we start thinking in terms of positions, okay, or indexes, then that would be a case where we would want to do for I in range, okay? But if we start talking about things in terms of values, right? If it's like, oh, I just want to print out all the values, 10, 20, 30, 40, 50, 60, 70, 80, 90, like how we started the class, right? If it's just about printing out values, you could really do either one. You could make it work both ways. And we saw that both ways actually worked for that example, right? But it was only then when we started talking about the diagonal, where it's like, oh, they have to have the same index for the row and the column, okay? That would be a case where, since we're talking about positions and indexes, we would do for I in range, okay? Are there any questions on that concept? It's definitely a very important concept. Any follow-up questions? Yeah, Arnold?
So it seems like the first method is when something is going to be done to everything in the list, or everything that's being iterated through.
So, look, I want to be clear, like both of these, for I in range, and then let's just say like for each num in LST, okay? These are like the two templates. I think these are still quite similar, okay? Most of the time you can use either one.
Okay.
The only thing is when we're using this second one, okay? There is this like one additional step where it's like value equals like LSTI, okay? Let's say we were doing something like len LST, okay? So let's just look at lines 21 and 22. The difference between these, okay, is that on line 21, let me move the cursor. On line 21, we are going through the indexes, okay, but we can still access the values themselves by just using that index, right? We just do LSTI, okay? This one, maybe it's just like one less line of code if we just wanted to print out each num, you know? We would do something like print each num. But I definitely want to highlight that these two generally do very similar things, okay? The way I think of it more is like, I could use either one of these, but if the question makes me care about and think about positions, like indexes or positions, if I have to care about that, then I want to have the flexibility to be able to access the index, okay? If I want to do anything with I besides just doing LSTI, then I would want to use this, okay? And in that example with the diagonal, okay, I had to do more than just get LSTI, remember? In that example, I think I still actually have it open here. In this beginning example, okay, I wasn't just accessing things using I and j, right? I had to use the positions in a Boolean condition, right? Because we were like, the only time something is on a diagonal is when the indexes of the row and column are the same. And so if I need to care about positions, and we clearly did here, if we care about positions, then I want to use I and j so that it's easy to compare the positions. Does that make sense? Are there any questions about this? It's great that we're talking about this because for images, we're going to really have to care about how we iterate through the different rows and columns, okay? Any more questions here? Awesome. Okay, let's keep going through this. Please, though, interrupt if you do have questions and want to revisit something that we did earlier. So we know images are just collections of pixels, okay? Images are collections of pixels that are just in a grid. So this does make it seem a little bit more complicated though, okay? Because here we have a 2x2 grid, okay? A 2x2 grid, just like what we were doing earlier. That was a 3x3 grid, right? We had 3 lists and 3 things in each list, okay? Here we have a 2x2 grid, but instead of each thing inside being a number, right? Before it was just like each thing inside the smaller list was 10, then 20, then 30. Now, instead of a number in each position, it's going to be a pixel, okay? But remember, pixels are tuples. So now we're starting to get like a mix of bunch of things, right? Let's actually show an example of what an image would look like, okay? So we would actually say we have like, let's just say black equals 0, 0, 0, and red equals 255, 0, 0, okay? Let's say I wanted to make an image, okay? Let's say I wanted to make an image with a black row, a red row, and one more black row, okay? So I wanted 3 rows, okay? I wanted 3 rows, and let's say I want the things in the row to all be the same, okay? So let's actually redraw this just next to our previous example, so it's a little easy to compare, okay? Let's say I want to make a 3x3 image, okay? So it'll be like 3x3, and I want this to be black. I'm just gonna put B for black, R for red, okay? Let's say I just want to make a 3x3 image. Instead of having numbers, okay, these are going to be pixels that are colors, okay? So now, let's just think of what we would actually have to do to create that, okay? I am still going to have a list within a list, okay? That's something I want to be clear on. I know we're learning about tuples, but we are still just caring about a list of lists, okay? A list within list. But inside those smaller lists, it's not numbers anymore. It's pixels, which are tuples, okay? So this would actually be something like, and remember, we already have these variables, black and red, okay? This would actually be something like black, comma, black, comma, black, okay? And that first inside list would be done, okay? This is just going to be the top row of our image. It's going to be the top row of our image. And each of these things is a tuple, okay? One thing that helps a little bit is these pixels, I know they're tuples with like 3 things inside of it though. We don't really have to like iterate inside or look at each of these, okay? I still just think of a tuple as like one entity, okay? Even though it's like a collection of 3 different things, okay? It all just comes together to make like one colored square, okay? So So I know we're starting to really get into like a list of tuples, but I think you can simplify the problem a bit by thinking of tuples as just like a single unchanging block of color, okay? And so if I wanted to make an image that's a 3 by 3 image with black, then red, then black as the rows, it would look very similar, or it would be this, okay? And then black, 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 okay? So, what I've done here though, is just make a variable called black that is this tuple, okay? I think I've done this intentionally just so that it's not like so many numbers and brackets and parentheses at once. But if we really want to get technical here of like what this image would actually be, okay? It would really be like this, 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 and then I'm just going to replace all the black ones with 0, 0, 0, and then like this, okay? This is really what an image looks like to the computer, okay? The computer is just like, wow, I have this like bunch of numbers and parentheses and commas. This is like exactly how a computer interprets this. But what we see, okay, what we see when we actually like convert this to an image, which we'll talk about this probably in next lecture, but you see how these images have like .jpg or .png, okay? These are just like file types of images. And so when we see a JPG file, we see this cat, right? But what the computer actually sees is like, I think it's like 600 by 400 pixels, okay? Where each pixel is like, this is like a dark red or black pixel or something, and the eyes will be like yellow pixels, okay? Is that clear? Okay. So, this is what a pixel looks, or this is what an image looks like. For right now, I haven't actually ran this or showed you like proof that this is an actual image, okay? And this would show like red, or like black, then red, then black. But how are we going to do that in this week, okay? We're going to be learning about images all week. So, this is going to be a really important concept, okay? We are going to have some existing code, okay? Some existing code called the CSE8A image library, okay? This code is going to be responsible for letting us create images and manipulate images, okay? We have about 12 minutes left, which is perfect. I actually want to show you how you can start using some things in the CSE8A image library, okay? And I want you all to actually just open it right now, okay? And what I mean by open it is if you go to this second thing in lecture 13, okay? You might already have it open. And if you click on files, okay, and click on files in the top left here, you can actually see that there is a file called CSE8A image.py, okay? You can click on the file there, or I think you'll already have the tab, okay? So let's actually just click on it and see what we are dealing with. Let's see what we are dealing with, okay? Now, to be clear, this has a lot of advanced code that you don't need to understand, okay? You don't need to understand what like each individual line in this file is doing, okay? Instead, what you need to do is just learn how to use some of these functions, okay? And so as you're reading this code, this like bunch of code first, let's not focus on these like inside lines, okay? Let's just look at the names of the functions, okay? Let's see, this first function is load img, okay? Oh, you know what actually? I should have put, there's a table that we have that describes what each of these functions are, okay? You can actually find that function. Let's just open PA5, okay? Let's open PA5, or at least I'll do that right now to show you. And if you go to like the second assignment, that is, one of the image manipulation things that you'll do, you can actually see this table, okay? To be clear, this should have also been in your lecture 13. I just forgot to add it, okay? But this is going to be super useful, okay? Right after lecture, I'm going to add it to the lecture 13 write-up so that you can actually see it all in one place. But you don't have to understand all that code that I was just showing. Instead, what you have to understand is what each of these functions does, because you will use each of these functions, okay? So that first one was called load img, okay? And I can actually even put, oops, let's show it over here, okay? We have all this code for load img. You do not need to understand it, but instead you should know that like it'll take in some input parameter, and in this one it's file name, okay? So we have to use this function by entering some file name, and what it's going to do is return a 2D list representation of the image, okay? So I can use this load img function to read in some image, and then I will get all the 2D list showing all the pixels, okay? So let's actually see what this looks like. I'm going to keep that tab open, and I'm going to have lecture 13 open just like we had before, okay? And I'm going to remove this code. So one thing that's super important here, okay? One thing that's super important is this thing that's line 1, okay? You should never remove this import statement, okay? Because that is what allows us to use functions from a different file inside of our transformation.py file, okay? We can actually use functions from a different file in the file that we're working with. And we've actually seen stuff like this on line 1 before. Remember when we played that guessing game and we had something like import random, okay? We had import random earlier. We also had like import math. These are all doing the exact same thing, okay? Except the difference is that on line 1, we are importing code that we have already written, right? On line 2, we are importing a built-in like file basically that the people who created Python decided to like give to everybody, okay? So the big picture here is to keep this first line, because now we are going to start doing things with the functions in the other file, okay? And so I actually want to show you how can we use load img with this input file name, okay? So I'm going to create a variable called cat img, and I want to make that equal to load img, okay? So just what I'm doing here might already be a little bit confusing, because normally when we use a function, okay, we've seen that function be defined in the same file, right? Usually we write the function, and then below it we use the function. But because we have this line, we can use any function that is in that file, okay? So we are going to do load img, and let's look at the documentation, okay? This table I'm going to call documentation. It's going to tell us exactly how to use that function. I have to input a file name or a file path as a string, okay? It specifically tells me the type that the input has to be. And so I'm going to put, what is the file path here, okay? This is something that's not so straightforward. Let's say I wanted to load in the cat image, okay? Would I just put something like cat.jpg? Would this work? Yeah, Arnaldo?
That's what I would have done. I would have.
Yeah, so I mean, so here's the thing, right? I really want to emphasize this concept. If we don't know if something is going to work, let's just try it and run it, okay? Let's let Python answer that question for us. No such file or directory, cat.jpg, right? JPG, I'll call it JPEG. But we can see it right here, right? It obviously exists. So instead, this is going to be really important. I think a lot of times we get tripped up by this. We have to put the name of the folder first and then the backslash, okay? Or the forward slash. The full file path, okay, because we are working in transformation.py, if we want to get something inside another folder, okay, we have to say the name of that folder and then the slash and then the file that we care about, okay? So now I'm going to try running this. Awesome, right? I got no errors. I'm not seeing anything, but that's fine. We don't have a print statement, so we shouldn't see anything. But I ran it, and now I know at least this is working, okay? And so, remember, this was sort of like a long demonstration because I wanted to show like about this, like, you know, what I have drawn on the board there, that we have a row of black, a row of red, and a row of black, right? I wanted to show you proof that this is actually how the computer processes an image, okay? So just for now, I'm just going to do this. I'm going to print cat img, okay? I'm going to print cat img. So remember, load img is just going to give us the 2D list representation, right, of whatever this image is. So then if I print it out, okay, is it going to show me a picture of a cat, or is it going to show me a lot of numbers? Does anybody have a guess? Were you going to say something, Isabel?
A lot of numbers.
A lot of numbers. Okay, let's see if that's the case. If I run this, I just get a bunch of numbers, okay? But let's try to, I think it should stop soon, but let's just try to pause it for a second. Okay, let's actually just highlight one of these things, right? One of these things we can see, let's make it really big, okay. We can see that each of these things that is getting printed out between the commas is, you know, the parentheses and then 3 numbers inside of it, okay? This is a pixel, okay? But the computer is interpreting it as, you know, the red, green, and blue values, okay? So when I ask the computer to load in this image and then display whatever it loaded in, okay, it's displaying it in terms of pixels, which are just numbers to the computer, okay? So that is how we would use load img, okay? Now the way that we are going to use this whole library going forward is we're going to load in some image of something, okay? We're going to load in like the image of a cat. By the way, this cat, you're going to see so much in the next 2 weeks, okay? Like this is going to be like burned into your memory because most assignments that we use, okay, that we do regarding images will have like some of these stock or like template photos. You could actually like upload your own photos that you're interested in manipulating or like changing, okay? But this cat will just give you as like the basis for most of these assignments, okay? And the way that the workflow is going to go, I'm just going to describe it in English because we don't have the time to get into it for the rest of this lecture. But let me actually write it in a comment, okay? So first we are going to load in an image, and then we are going to go through the image pixel by pixel, and then we are going to modify certain pixels, okay? We're going to modify certain pixels. These are kind of like the 3 steps that image manipulation like can be boiled down to, okay? But in simple terms, okay, we're not doing anything that different from like what we started today's lecture with, okay? We are going to, load in an image. That just means we're going to get a 2D list of things, right? And then we're going to go through each pixel, or go through each value. That's just going to be like the list within list that we started, the nested for loop, right? We had for I in range and for j in range. We're going to do something very similar where we go through pixel by pixel or value by value, and then we're just going to make some changes. Like we would maybe change this 10 to 20, or change this 20 to 40, like if we wanted to double everything in the list, okay? At a high level, we are doing something that I think we are mostly capable of doing right now, but the difference is that we're doing it to this thing called an